Good day, M2. This is Teacher Win and welcome to our last lesson for Unit 5. For this video, we are going to learn about potential energy and kinetic energy. To know more about this lesson, you can follow page 70 to 75 of your science book. Let me begin first about kinetic energy. Say it again. Kinetic energy. So kinetic energy is the energy an object has due to motion. So just remember M2 that if we talk about kinetic energy, we're talking about energy in movement. So as long as you are moving, then you have kinetic energy. So like for example, so we have here your space rocks, your meteors. You have here your walking, falling, flying airplane, or throwing a ball. So all of them has motion. All of them have movement. So therefore, all of them possess your kinetic energy. In order for you to compute or calculate how much energy does an object have, so you can use this formula which is expressed in Ke is equals to 1 half mv squared. So your Ke here is your kinetic energy, your m here is your mass, and here your v is your velocity. So please take note of the units. For kinetic energy, so we will use joules as its unit. Mass, we will use kilogram, and v for velocity, we are going to use meter per second. Now, let me ask you, what will happen if we increase the mass and we also increase the velocity? So let's have a short walkthrough about this one. So we know already that kinetic energy is equals to 1 half multiplied by your mass and then your velocity squared. So this is very common problem to physics, that physics questions wherein you're asked what will happen if you increase the mass, what will happen to the kinetic energy, what will happen to the kinetic energy if you increase the velocity. So in solving this problem, I want you to remember, okay, so normally I do like this. When I am asked about these questions, I usually eliminate this one and the remaining numbers, so I convert it into 1. So like for example, if I increase the mass, so like for example, I will put mass as 2, so I will just place velocity as 1. Okay, so in here, like for example, also here, so this is the normal equation, right? So this is just a question asking if what will happen if velocity is increased. So I just normally remove this one, and again the other variables or the other part of your equation just set to 1, because your question here is about velocity. So what if I increase this one into 2? So to make it simple, so something like this, so you just multiply like mass and v squared, right? So if I multiply mass by 2, let me just adjust this one. So multiply mass by 2 and then squared the value of velocity. So 1 squared, that is still 1. So multiply by 2 and then you will have 2. So that means your kinetic energy has been increased by 2 folds. For the case of your velocity, so you have here like the value of velocity increasing to 2. So mass here is 1, then for velocity you have 2, so 2 squared, so that will be 1 multiplied by 4, so you will get 4. So the kinetic energy is increased by 4 times. Okay, so therefore, what will happen if the mass is increased? So the kinetic energy, so if the mass is increased, then the kinetic energy is also increased. Okay, so what will happen if velocity is increased? So if you increase the velocity, then the kinetic energy will also increase. Now let's have this word problem about kinetic energy. So what is the kinetic energy of a stone with a mass of 2 kilograms having a velocity of 5 meters per second. So, like for example, this is the stone, and the stone is moving. Okay, so shall we say it's moving to this way, and it's moving at a speed of 5 meters per second, or a velocity at 5 meters per second, and the weight of the stone is 2 kilograms. Okay, so we are asked about the kinetic energy. So our given here to solve this equation, so Ke, then we have your mass, and also we have your velocity. Where in your Ke here, your kinetic energy, so we don't know yet. Then the value of our mass is 2 kilograms. And then the value of velocity is 5 meters per second. So what will be our formula to be used? So we are going to use your Ke is equals to 1/2 mass and then velocity squared. So our solution, that would be, so the value of Ke is x, the value of mass is 2, and then the value of velocity is 5 squared. So that's 1/2. So then 2, and then 5 times 5, or 5 squared, that will be 25. So 25 multiplied by 2, very good, that's 50. Multiply by 1, that will be 50 divided by 2. So 50 divided by 2, and you will get, okay, very good, 25. But again, we are asked about your Ke here. So what is the unit? Very good. So it is expressed in joules. So this is your final answer. So therefore, this stone, which is 2 kilograms and is moving at 5 meters per second, so the kinetic energy it has is 25 joules. The next word problem is 2 kilogram mass is moving at a constant speed. If its kinetic energy is 400 joules, what is its speed? So this time we're asked to solve for speed. So like for example, so if this is like the object that is moving at a constant speed meaning it does not change the speed. So if it means it's running at 10 meters per second, then it is moving at 10 meters per second. So the weight of this mass is 2 kilograms, and then its kinetic energy is 400 joules. So let's write the numericals. So for Ke, so Ke here is 400 joules. Then the value of mass, so we don't know yet. The value of velocity, so I mean the value of mass is here already, so that's 2 kilograms. And then the value of velocity, so we don't know yet. So formula, so that will be Ke is equals to 1/2 mass and velocity squared. So our solution, that would be, so Ke is 400, and then the value of mass, which is 2, and then the value of velocity, and we don't know yet, so that will be 400 is equals to, okay, so 1/2 2 then x squared. So 2 times x squared, that's 2x squared, times 1, that will be 2x squared. So 400 is equals to 2x squared over 2, right? So therefore, we are going to divide this one by 2. So 2 divided by 2. So you'll get a value of 400 is equals to x squared. Take note that this is a squared, so we'll get the value of your square root. So let's just move to this side. So square root of 400 x. So therefore, the value of our x is 20. 20 what? 20, so because this is speed, so this will be 20 meters per second. So therefore, the weight of this object, which is 2 kilogram, is moving at a speed of 200 meters per second. Now, let's move to potential energy. So, potential energy is stored energy held by an object because of relative position, electric charge, or internal stress. So, just remember potential energy is stored energy, meaning you have that energy without moving. I mean, if you move, okay, so that potential energy will become a kinetic energy. So something like you have a ticking time bomb that you are holding and you're just waiting to explode. So that is like your potential energy, by which it can be seen when you raise the object, or it can be in an object like your dynamite. And then if you're pulling the string of your bow, and then if you stretch the spring, or even your battery, so potential energy can be found mostly if you raise an object, or in chemical energy as well, or elastic. Okay, elastic, like for example this one, stretching the bow and the stretching of your spring. But for this video, we are going to focus more about this one, uh, positioning the object according to its height. Now, what we have here are your metal balls, and let's just imagine that you are holding the 20 kilogram metal ball, by which you position the metal balls in different height. So like for example, this ball here, you position it at the height of maybe 1 meter. This one at the height of 2 meters, and then this one at the height of 3 meters. Okay, so this is the only difference. The difference is the height. They are the same with weight, and then the direction of your force, which is downward. So my question is this one: which do you think has a higher potential energy? Okay, so very good. So remember that your potential energy is the stored energy, which is influenced by the three things. Number one, your potential energy is influenced by your mass. So an object that has mass will have potential energy. What else? The influence of your gravity. So gravity. And then finally, with the influence of your height. With your height. So again, so M here is your mass, which has a unit of kilogram. Your G here, which is your gravity, which has a unit of meters per second squared. And then for height, which has a unit of M. So looking at the formula and doing mental computation, so which object has a higher or has a more potential energy? Maybe for convenience, let's have this one object A, object B, and object C. So which do you think? Okay, very good. So if your answer is letter C, then you got it right. Because number one, if you look at the mass, all of them are the same, right? For gravity, all of them have the same gravity. So you made this experiment on Earth, so they have the same amount of gravity pool, right? So the only difference is their height, because ball C has a height, or you put the ball C at a height of 3 meters, right? Compared to your ball B and ball A. So again, the question is, which ball has more potential energy? So the correct answer is letter C. So once again, so this example here, so you have here a boy holding the ball, and the ball has what kind of energy? Potential or kinetic? Okay, very good. So this is a potential energy, right? Or the ball has potential energy because the ball is not moving. And I mean, the ball has been held by the boy at this specific height. So like for example, so let's compute the potential energy of this ball. So like for example, the height of the ball is, shall we say, the height, okay, from this area is, shall we say, maybe 10 meters. Okay, and then the weight of this ball is 10 kilograms. Okay, so let's try to compute its potential energy. So knowing the formula already with m, g, and h, mass, gravity, and height. So potential energy for this ball will be, okay, what's the value of mass? That will be 10. How about the value of gravity? Okay, very good. So the value of gravity is constant. So that is 9.8 meters per second, right? But for convenience, so we will just use 10 meters per second squared for easy computation. Okay, so multiply it by 10. And then the height of the ball is 10 meters. So therefore, so the potential energy is, simply multiply this one, 10 times 10 times 10. So 10 times 10, that's 100, times 10, that's 1000. So 1000 joules. So the potential energy of the ball at this height is 1000 joules. Or you can just simply write 1 kj na? So 1 kilojoule, because K here means kilo and kilo is 1000. So 1000 times 1, you will have 1000. Now, what will happen if you drop that ball from that point? So shall we say the ball now is moving at this point, right? So what is now the energy does it have? So very good, it has now a kinetic energy. Remember that kinetic energy is moving energy, right? So from stored energy now into moving energy, so that is kinetic energy. So what is the value of kinetic energy here? Okay, very good. So remember that from your potential energy, you convert. The word is convert. Okay, you convert it into kinetic energy. So that means if your potential energy is 1000 joules, so this is for the potential energy now, and then you just convert it into kinetic energy, so that will still be having 1000 joules na? Because you just change it from one form to another form. So therefore, the kinetic energy of this ball is still 1000 joules. Okay? Now, the follow-up question is this one. How fast does this ball move, right? So how do we compute the speed of this ball? So basically, so we will go back to your equation of your kinetic energy, which is your 1 half multiplied by mass and your velocity squared. So we're in. So from the previous example, the mass of the ball is 10 kilograms, right? So kinetic energy, that will be 1 half multiplied by 10, and then that will be v squared, by which our kinetic energy here is 1000, right? So 10 multiplied by v squared multiplied by 1, that will be 10 v squared. So 1000 is equals to um, 1000, that's 10 v squared divided by 2, right? So by which we can divide 10 by 2, and you will get 5v squared, right? So, and then 1000 divided by 5, then divided by 5. So 1000 divided by 5. So I will just move the equation here. So you will have 200. Okay, is equals to v squared. So again, where did I get 200? If you divide 1000 by 5, and you will get 200. Okay, so remember, this is v squared. So you're going to get the value of your, the square root of 200. So how much? Can you tell me? Okay, very good. So you will have a value of 14.14 meters per second. So this is the value of your speed. So therefore, this ball, which weighs 10 kilograms and has a kinetic energy of 1000 joule, is moving at a speed of, or has a velocity of 14.14 meters per second. So looking at our word problem for kinetic energy, so 4 kilojoules of work is done to pull a bucket of mass 1 kilogram carrying 24 kilograms of water out of a well. So how deep is the well? So this is the well, and this is the bucket, and then this is the person doing the work, exerting a 4,000 joules of energy, because this is kilojoules. So the weight of the bucket plus the water, that will be 25 kilograms. Again, the weight of the bucket now is 24 kilograms plus 1 kilogram, so that will be 25 kilogram. And then the well, we don't take it in the equation. So looking at our given, we're asked about how deep, right? So we are going to compute the, what do you think, potential or kinetic? Okay, very good. So we are going to compute the height. Okay, so remembering the formula for potential energy. So the formula for your potential energy, so that will be PE is equals to mass, gravity, and height. So for PE, that will be 4,000. The mass is 25. And then the gravity, the value of your gravity is 10 meters per second squared. Okay, and then for the height, so we don't know yet. Okay, so PE here is 4,000 multiplied by your mass, which is 25, by the pull of gravity, which is 10, and then for height, which is x. So 25 times 10, so you will have an answer of 250. So 4,000 is 250x. So we can just multiply by 250 and 250 here, so that we can cancel it out. So what is now the value, or how deep now is your well? Okay, very good. So the deep, or the height of the well, is now 16 meters. Okay, very good. So the height of the well is 16 meters. And then this is the last word problem. So you have here a ball, and then you require at least 1000 joules to carry it up to the stairs that are 12.5 meters high. So you are asked about how heavy is the ball. So let's have first our given. So our given here will be potential energy, which is 1000 joules, and then mass here, wherein we don't know yet. Gravity here, that will be 10 meters per second. And then the height, which is 12.5 meters. Okay, so formula, we will just compute for PE is equals to M, G, and H. So what will be our solution? Potential energy here is 1000 is equals to mass, which is x, gravity, which is 10, multiplied by 12.5. So 1000. So M2, 10 times 12.5, Okay, so you have a value of 125x. Okay, so what are you going to do next? So you have to divide it by 125, both sides, so you can cancel this one. So 1000 divide by 125, what is the value? Okay, so very good. So the mass of this object is 8 kilograms. So what is the weight of the ball? So the weight of the ball is, okay, 8 kilograms. Okay, very good. So this is the end of the video M2. So I hope you've learned already about potential energy and kinetic energy. So once again, thank you very much for watching and have a nice day M2. Goodbye and stay safe always. Take care.